Good morning, good evening, good afternoon, boys and girls. So let's talk about IPv6 NAT concepts. NAT and PAT is actually port address translation and network address translation. This is a professional presentation with some of the networking fundamental terms. So let's start working on this. Okay, we will cover the following topics: introduction to NAT, private versus public IP addressing, NAT types, PAT, which is also known as NAT overload, NAT tables, pros and cons, IPv6 NAT concepts, MPTV6 and NAT6, comparison, use cases, troubleshooting, security, future of NAT, and a summary of these concepts. So let's start with the first slide. What is NAT? What comes to your mind when you think about NAT? Network address translation allows private IP addresses to access the internet using public IPs. None of the private IP addresses ranges are 10.0.0.0/8, 172.16.0.0/12, 192.168.0.0/16. And these are intranet. So let's just remember that. These are intranet. This can be part of an intranet, which is a company, any company. And these are known as private IP addresses, and these are the ranges. When we talk about public IP addresses, those are globally routable addresses. Okay, let's continue learning about this. What are some of the basic concepts regarding NAT? NAT translate inside local to inside global addresses. Is used for IPv4 address conservation. Static NAT, what do you think about static NAT? One-to-one mapping between local and global addresses, useful for servers needing consistent IPs. So these are the two definitions that we have for static NAT. Basically, NAT is a mechanism to avoid IPv4 addresses exhaustion, meaning it allows us to have enough IP addresses for all the companies around the world. What is dynamic NAT? Let me just clear this. I'm just going to clear everything. It maps private addresses to a pool of public addresses dynamically. PAT, NAT overload. Multiple private addresses share one public IP using ports numbers. That is the definition for NAT overload or PAT. When multiple private addresses share one public IP using port numbers. How does PAT works? PAT assigns unique source ports for each session, enabling many hosts to use one IP. What is an example of a NAT table? Okay, so this is a private IP address with a specific port, and this is a public IP address with another port. And the first one is an inside local, and the other one is an inside global. So there you have it. We have the inside local and the inside global. That's what we have there. Now let's clear the drawing, and what do you think can be an advantage of having NAT and PAT? Some of the advantages are address conservation, improved security, easy renumbering of networks. What can be limitations of NAT and PAT that you can think of? Well, it breaks end-to-end connectivity. It causes issues with some applications, and we can have performance overheat. Overheat. So those are some of the limitations when we are using NAT and PAT. Introduction to IPv6. So we already talked little bit in previous lessons about IPv6 and how does it work. But let's just review a little bit. So let me just highlight this section. Private IPv6 provides 128-bit addresses solving IPv4 exhaustion. And this is an example of an IPv6 address per se. This is an example. This is the abbreviated version. We can have an expanded version, but this is the compressed, the abbreviation of the IPv6 address. Okay, let's continue moving on. Why do we need IPv6? There are some countries like Japan where they are integrating IPv6 in nowadays technologies. The reason is IPv6 reduces NAT need, but NAT6 and NAT-PTv6 exists for multi-homing policy and renumbering. Let's clear this drawing for a moment. Let's move to the red color again. IPv6 NAT types. NAT has some different types. In this case, we have, and this is actually a big NAT version 6 and NPT-v6. NPT-v6 is the prefix translation, and NAT v6 is the full address translation. Controversial. Interesting. So it's not really that much necessary in the sense that we don't need NAT anymore as much as we need it with IPv4 addresses, but it's still being used just for emergencies. Since IPv6 provides us more than 3 millions of IP addresses, and that is the main reason we don't need NAT that much as we used to need it with the IPv4 scenarios. Now, let me clear the board for a moment. And what can be an NTPv6 example? Is basically when it translates one IPv6 prefix into another while keeping host bits unchanged. And what is a NAT-v6 example in this case? It maps one IPv6 address to another and it reduces transparency. NAT versus IPv6 NAT. So IPv4, we can use NAT and PAT for address conservation. In IPv6 NAT is limited use, and we have MPT version 6 and NAT version 6. Those are the two options that we can engage and use when we're working alone with IPv6 addresses. Now, let me clear the board for a moment and let's talk about use cases and best practices. So NAT and PAT are used for internet service providers or ISPs and enterprise companies, large companies. NAT IPv6 is rarely used, mainly for prefix translation only and for emergencies. But that will be the main reason because we use the NAT IPv6 for prefix translation when required. Okay, let's clear the board. Let's move on. What is an example of a network topology? Okay, we talked before that ISPs and enterprises. So we can have a company that connects to New York. And it goes, and then it connects to Washington, D.C., Columbia, and then it connects to another company that is in Miami, Miami. And they are ISPs. They are internet service providers. They are ISPs. And they are sharing information, resources. They are providing internet to different customers. And the way it works is that each of those companies have NAT and PAT in the intranet per se. And that's a way to do the conservation of IPv4 addresses. That's the way it works. Now, let's clear the drawing for a moment. And what can we talk about troubleshooting for NAT and PAT? It's important to check tables, NAT tables, translations, and access lists, ACLs. An important command in Cisco equipment will be show IP NAT translations when we are talking about NAT. Now, let's clear the board for a moment and talk about security considerations. NAT provides basic obscurity, but is not a firewall. IPv6 NAT, it may reduce traceability. So it will give us some kind of security, but not all the security that we want in our networks. So it is important, even though we are using NAT for IPv4 addresses, to have our security in place, in this case, firewalls, when required to protect our networks. Next, let me clear the board. What comes to your mind when you think about the future of NAT? As IPv6 adoption grows, and I show you the example of Japan, that they are using more every day of IPv6 integration and technologies. NAT use will decline, but PAT remains relevant in IPv4 networks. So when it comes to IPv6, NAT is not necessary only for emergencies or for translation. It's not required so much. But when we talk about IPv4, we still need NAT and PAT, mainly for address translation in many of the intranets or internal networks for the different companies around the world. Finally, we have talked about NAT and PAT. Mainly these are solutions for IPv4 limitations. IPv6 reduces the NAT being needed per se. We don't need NAT that much when we are talking about IPv6. And it's important to understand that it is still useful because many countries like Latin American countries or companies in the United States, they are still using IPv4. They are still using NAT. They are still using poor address translation. So it's part of our day-to-day work per se. With that being said, this is the lesson for today. I hope that you have learned something about it. I will see you at the top of success. Boys and girls, it's been a pleasure. And until next time, take care.